Okay, now we're looking at predicting products for single replacement reactions. First thing we have to do is recognize that this is a single replacement reaction, and we can see that we have an element here by itself, and we have a compound. According to the rules of a single replacement reaction, the element that's by itself is going to replace the like element in the compound. And when I say like, I'm talking about metals. So here's copper, it's a metal. It's going to replace zinc because it is a metal. And really what it is ions. If we look down here at hydrogen, hydrogen is a non-metal, but it's going to act as a metal because it is a positive ion. And we'll see that in our activity series in just a second. So let's go ahead and take a look at number one. Actually, before we do that, we have to recognize that in order for that reaction to take place, the element that's by itself must be more reactive than the element that it is replacing. And to do that, or to reference that, we're going to look at our reference sheet at our activity series. So here we have copper. It's going to want to replace zinc. But in order for that to happen, copper has to be more reactive than zinc. So let's go over to our reference section. Here is our activity series. And we will see that copper is right here. And zinc is right here. So zinc is more reactive than copper. So now I can go back here. Zinc is more reactive than copper. Since it's more reactive than copper, it's going to stay put. It's going to stay bound to that sulfate, and no reaction is going to take place. So I would write NR for no reaction. In order for that reaction to take place, copper has to be more reactive than zinc. So we get no reaction. Let's go down here and take a look at number 5. We have barium and nickel phosphate, specifically nickel 2-phosphate. So again, barium has to be more reactive than nickel in order for this reaction to take place. Let's look at our activity series. So barium is right here, third from the top, and nickel is down here. So barium is more reactive than nickel. So since that is true, these will go ahead and switch places. So now I'll have barium bound to phosphate. And this is extremely important. This is no different than formula writing. This is formula writing. I have to write the correct formula for barium phosphate. So barium, if I look at the periodic table, has a positive 2 charge. And phosphate, if I look on my polyatomic ion reference sheet, has a negative 3 charge. As a result, I need 3 barium atoms and 2 phosphate ions to make the correct formula. So this should be Ba3PO42 plus nickel. And nickel is not going to have a subscript or anything. It's not a diatomic element. That is one thing you have to be aware of when working with your single replacement reactions. If you have an element that is left by itself and it is a diatomic element, then it will have a subscript of 2 like all diatomic elements do when they are left by themselves. And you have to be careful to make sure that you write your formulas correctly.